Hello friends, myself R.D. Mahajan presenting my video on Newton-Raphson method. Example, find by Newton-Raphson method a root of equation x cube minus 3x plus 1 equals to 0 correct to 3 decimal places. As we require to obtain answer correct to 3 decimal places, fix your calci for 3 digits by performing mode, fix and then 3 digits, so that answer will be in 3 digits only. The equation is x cube minus 3x plus 1 equals to 0. We have to obtain the root of that equation by Newton-Raphson method. Therefore, f of x is x cube minus 3x plus 1. Differentiating it with respect to x, we get its derivative as 3x square minus 3. Differentiation of 1 is 0. And then to obtain the root of the equation, we have to obtain two initial guess values. Therefore, when x is equals to 0, we get f of 0 as, substituting x is equals to 0 here, this is 0 minus 0 plus 1. Therefore, 0 minus 0 plus 1, we get that value as 1, which is greater than then for x is equals to 1, we get f of 1 as, therefore for x is equals to 1, we get 1 cube as 1, minus 3 into 1 as 3, minus 3 and plus 1. Therefore, minus 3 plus 1, we get 2 minus 3, we get minus 1, which lies between, root lies between two values, x is equals to 0 and x is equals to minus 1. And out of these two values, we have to consider one of them as initial guess value. For x is equal to 0, we get 1 as the function value, and for x is equals to 1, we get minus 1 as the value, whose distance from 0 is same. Therefore, we can consider any value as x0. Therefore, let x0, or we can consider x0 as 1. In same number of iterations, we get the required value. And therefore, substituting that value here in these two equations, we get f of 0 as, which already I have calculated, f of 0 as 1, and f dash of 0, substituting that value of x as 0 here, we get 0 minus 3, therefore it is minus 3. By Newton-Raphson formula, we have first iteration x1 is equals to x0 minus f of x0 by f dash of x0, and therefore it is equals to, substituting the values, the value of x0 is 0, f of x0 is 1, and f dash of x0 is minus 3, and therefore it is 0 plus 1 by 3. If we calculate that value by calci, we get that 1 by 3 as 0.333 as first approximation for the root, or the first value of the root. Then check it whether it is root or not by substituting that value here once again in fx. Therefore, f of x1 is equals to 0.33 cube minus 3 into 0.3x minus 0.3 into 0.333 and plus 1. And if you perform that calculation by it is 0.038. If it is nearly 0, we stop the procedure. As here the value is not equals to 0, we have to continue that iterative procedure. Iteration number 1. Then we go to the iteration number 2, where we try to find the value of x2. For second iteration, we have x2 is equals to x1 minus f of x1 by f dash of x1, where x1 is 0.333, previous approximation for the root. Corresponding function value is 0.038. Then substituting that x here to get f dash of x1 as 3 into 0.333 square minus 3, and by calci its value is minus 2.667, and then substituting all that values here in this, we get x2 as x1 0.333 minus f of x1 0.038 divided by f dash value is minus 2.667, and therefore it is 0.333 minus minus, it becomes plus 0.038 divided by 2.667, and if you perform 0.347 is the value for x2, and then we check once again where this value we can say as the root or not by finding the value of function at that point, and therefore f of x2 is equals to 0.347 cube minus 3 into x 0.347 and plus 1. Uh, 0.001, and whenever we are performing the calculation correct to 3 decimal places, if first 2 decimal are 0, then we can stop the iterative procedure, and as function value is 0.001, we can stop the iterative procedure. And therefore that value of x 0.347 is the required root. By Newton-Raphson method. Therefore, to obtain that desired root, we require only 2 iterations or 2 steps. Therefore, Newton-Raphson method is the fast converging. We require minimum number of steps to perform or to get that desired root. Therefore, if you are watching my videos, please like, share, as well as subscribe to my channel to get new updates or new videos. Thank you.